Hello, everyone from Engineering Math who's here for help on a couple of the homework problems. For those of you watching at home, I'm going to be doing problems 11, 15, and 19. This is for our units review. These are going to be full solution problems. We're going to be working from the beginning to the end, trying to use good problem solving technique and as much explanation as I can put in to a short video. If you're just looking for one of these, you can skip ahead. There should be links down in the description to the different sections. With that being said, I'm going to go ahead and turn off my face and let's get started. So to start with, here is problem 11. We are going to be designing an IV drip for a patient who needs 2.4 liters of saline administered over 8 hours. The tubing delivers fluid at 25 drops per milliliter, and you need to set the system in drops per minute. What should be the drip rate? All right, so the first thing we're saying is, what are we trying to find? What we're trying to find is drip rate that we need to set the system in. So that is going to be in drops per minute, right? That's the drip rate. So that is our success criteria. Once we find that, we know we've won the game. So we're trying to find drops per minute, right? What we are given here is we know they need 2.4 liters over a period of 8 hours. And we know that the tubing that we have will give 25 drops for every milliliter. So our strategy that we're going to go here, as we have talked about before in class, we're going to start from what we're trying to find and try to work our way to do that using conversions and our givens. So we need to start with drops. Drops has got to be in the numerator. Drops in the numerator because we've got drops in the numerator. We want time to be on the bottom, but we're going to start with drops in the numerator and then use our givens and conversion factors. Right? All the conversion factors that we might need, we can look up. Some of them we might know off the top of our head, but that's where we're going to start. All right, so let's go ahead and put drops in the numerator. Our only given with drops is here we have 25 drops for every milliliter. Let's go ahead and make ourselves a long fraction bar for this. Here's our start. Now we're going to use our other given here. So we can notice, that we've got down here we've got volume, milliliters, right? And so we're going to put our other volume on top so it'll cancel out, right? 2.4 liters over 8 hours. But this is liters and this is milliliters. So we are going to need to do a conversion for that. We know that a milli means 1,000, so there's 1,000 milliliters in a liter because milli is for thousandth. And we want to, if we want to cross off milliliters, we need milliliters on the top, right? So we're going to have 1,000 milliliters on the top and then liter on the bottom. That will get rid of our milliliters and that will get rid of our liters. And now we have drops per hour. What we want is drops per minute. So we got to do one more conversion, right? To get rid of hours, we're going to put hour on the top, and an hour is 60 minutes. So that gets rid of our hours, and we're left with drops per minute as our only units that are left. Now I can put this in our calculator, 25 times 2.4 times 1,000, and then divide by the things that are in the denominator, divided by 8, divided by 60, and that will get us 125 drops per minute as the setting we want for our machine. All right, now we're going to move to problem 15. This says we got a factory, has 4 machines that each produce 500 parts per hour. So I'm looking at you industrial engineers. Each of these machines runs 75% of the time during a 10-hour shift. So we got 75% uptime, 10-hour shift. If every part must then be inspected by one worker who can inspect 200 parts per hour, how many workers do you need so inspection keeps up with production? Okay, so there's a decent amount going on here, but again, let's start at the beginning. what are we trying to find? What is our success criteria? Well, it says how many workers. So what we're trying to find is a number of workers. Okay, let's look at our givens. What we know we have 4 machines. We know that each machine produces 500 parts per hour. So one machine, this is a conversion factor now, one machine makes 500 parts per hour. Now we could do parts per hour like this and put hour on the bottom, but now we've got a denominator in a denominator, which means we can just put hour on the top. So one machine in an hour can make 500 parts. So let's go ahead and do that, and let's go ahead and erase this down here. Generally, when we do things per something and we're in the bottom, the part that comes after the per can go up to the top. So we have one machine makes 500 parts per hour. The hour goes to the top because it's in the denominator of the denominator. All right, so there's a conversion factor. One machine times hour is 500 parts. We also know that they have 75% uptime. Percentage has no units. So we'll have to include that in our answer as a given, but it doesn't have any units at all because it's just a number, percentage. And we know they work for 10 hours. We also know that one worker has a working rate too, just like the machine. So one worker can do 200 parts, again, per hour. So one machine hour makes 500 parts, one worker hour makes 200 parts. Okay, so what's our strategy? Again, we're going to start by looking at what our success is. Our success is to find number of workers. So we're going to put workers in the top, in the numerator. And then we're going to use our givens and conversion factors to solve until the only thing left on the top is workers. All right, we want to get rid of all the other units except for that. So we look at our givens, we look at where we have for workers. This is our only thing with workers. So I'm going to start by putting that in the numerator. So we have one worker hour is 200 points, 200 parts. 200 points for this problem. No, 200 parts. Okay. So I need to get rid of hour and I need to get rid of parts down here. So we have one machine hour is 500 parts. If we flip that around and do 500 parts per one machine hour, then we can get rid of parts. So we have parts here, so we need something with parts on top. This is our only other thing here that has parts. So we can do this like this. 500 parts takes one machine hour. And what that does is that allows us to get rid of hours and get rid of parts. But now this is a ratio now of workers to machines. What I want is just number of workers. So I need to get rid of the number of machines. So we have 4 machines. So that gets rid of machines. However, we know that in a 10-hour shift, these machines do not run all the time. So if our workers are also working a 10-hour shift, the machines are only going to be up 75% of the time. So we also just need to include that 0.75 at the top. It's a given and there's no units, right? So we just need to change it from percent to decimal, right? So 0.75. You say, what about this 10 hours? Well, hours is already crossed off, right? Because the workers and the machines are working the same amount of time. So we don't need to multiply anything by 10 hours. That's extra information that we don't need to put in here because hours is already crossed off. So now what do we have left? We've got hours crossed off, parts crossed off, machine crossed off. this hour is crossed off. All right, so all that we're left here is the number of workers. So again, we need to put this in our calculator. 500 times 4 times 0.75 divided by 200 parts gives us 7.5 workers. Which means, by the time we put in the requisitions and ask management, we're probably only going to get 6 workers, and they're going to make them work harder. But really, ideally, we'd have 8, and then we'd have a little bit of downtime for everything. So, but we project that we need about 7.5 workers. Maybe you could get by with 7 if some of them are very well trained and can go faster. But that might change if we need, or if there's more downtime. Maybe the machines go down some of the time. Anyway, that is problem 15. All right, for problem 19, looks like we got a problem from our computer engineers. You're backing up files that total 96 gigabytes to a network drive with a sustained speed of 80 megabits per second. How many hours will the transfer take? Okay, and they tell us some of the information. We say 1 byte is equal to 8 bits, and they remind us that 1,000 gigabytes or 1,000 megabytes is 1 gigabyte. So again, what is our criteria for success? What are we trying to find? We're trying to find hours to transfer. So time is what we want, and we want time in hours, right? Our givens is that there are 96 gigabytes on this network drive. Our speed is 80 megabits per second, megabits PS. We know that 1 byte is equal to 8 bits. And we know giga is 1,000 megabytes. I almost lost my writing pad here for a minute. I had to pause. 1 gigabyte is equal to 1,000 megabytes. Okay. So let's start by, what's our strategy? Well, the answer we want is in time, right? We want time. So we're going to put time needs to be in the numerator. Time BN, that's not the way you want to say that. Let's go ahead and erase that. Time BN, maybe we'll just say it that way, right? Time, you know what time? Time be in the numerator. It'd be doing that these times. Time be in the numerator. And then, again, use our givens and conversion factors to get rid of all the other information. So where is time in here? Right, well, here we've got megabits per second. That's kind of the only one with time. So we're going to go ahead and start with that. Megabits per second means, again, we want to actually flip this one so the second's on top. So we're going to have 80 megabits in 1 second. And that's our given. And we're flipping it because we want time on top, because the answer we want is in hours. So we can go ahead and change that to hours right away, right? We've got seconds on top, so we're going to want seconds on the bottom. We know 60 seconds is a minute, and then we know 60 minutes is an hour. And again, we're just putting the seconds on the opposite side. You can, in some cases, we'll sometimes have 60 seconds on top and minute on the bottom. It just depends on where we're starting. Since we want time on top, we're going to end it up doing this way. Minute can also go right here. You can also, if you want to, just say an hour is equal to 3,600 seconds and just do one conversion factor. It's all the same thing. Now we've got hour per 80 megabits. So we need something that will get rid of megabits. Our only other given here in terms of amount of something is my 96 gigabytes. That's the amount of data. This is an amount of data. we're just going to need conversions to change this to be the same thing. So to start with, I'm going to go from gigabytes to megabytes. So here we have 1,000 megabytes is 1 gigabyte. And so that gets rid of the gigabytes. But now here I have megabyte, and here I have megabit. Now mega just means times a million. So we've got kilo is times 1,000, mega is times a million. It's one of our prefixes that we can have. And down here, the conversion they give us is 1 byte is equal to 8-bit. Now, what I can do with that is I can multiply each side by a million times a million on both sides. And that tells me that 1 megabyte is then equal to 8 megabits. Now, if you wanted to, you could do the conversion from megabytes to bytes, and then go from bytes to bits, and then from bits to megabits. But I think this makes sense too, right? Basically, if you have a conversion factor that works, as long as we add the same prefix to both sides, or take away the same prefix from both sides, it's always going to be the same. Because the prefixes are just like multiplying both sides by the same number. So I'm going to use that as my conversion factor here. So I'm going to say 8 megabits goes on top because we've got megabits on bottom. 8 megabits is equal to 1 megabyte. All right, so that gets rid of the megabytes here. That gets rid of the megabits here. And we're left with no unit, no unit. We've got hours. This one's gone out, no unit, no unit, no unit. Okay, and now we would just multiply the top, the numerator, 96 times 1,000 times 8, and then divide by 80, divide by 60, divide by 60. And that gets us approximately 2.67 hours. All right, everyone. Hopefully that was helpful. In the future, I hope to make more videos for this for you guys to practice too, maybe even based on problems that you guys are struggling with. But again, our strategy for units is, and for any problem, is to start with what your success criteria is. What is the thing we're trying to find? Then look at what we know so far. Then form a strategy, right? This is for every problem you should be doing this. And for units, the strategy is usually look at the unit of what the answer you're trying to get is and put that unit or a unit of the same type. So in the last one we were trying to get hours. We didn't have hours anywhere in there, but we did have seconds. So put a time unit on the top or a unit of what you're trying to get. Could be length, could be volume, could be charge or something. Put that unit in the numerator and then use the givens and the conversion factors along that bar so that we can cancel off everything except for that unit that we want. All right, have a good one. Talk to you later.